So this video explains the patterns of associations between two quantities and the influence of outliers. So a lifeguard at a local reef in Hawaii keeps track of how many shark sightings there were per month and how many swimmers came to the reef. So using this data, you need to describe the association between the two variables of the number of shark sightings and the number of swimmers at the reef. And then you need to determine if this is a linear or nonlinear relationship and if there are any outliers. So in this problem, you have two variables that are being compared to one another, the number of shark sightings and the number of swimmers at the reef. So let's think about this first. If the number of shark sightings went up, would you expect the number of swimmers to increase or decrease? Well, we'd expect it to decrease, right? You would expect the number of swimmers to go down as the number of shark sightings go up. What this is called here is a negative correlation. A negative correlation is when, as the x value increases, the y value decreases. Over here, the number of shark sightings is the x value, and the number of swimmers at the reef is the y value. Now in a positive correlation, as the x value increases, the y value also increases. Now let's see if this negative correlation is true. When there are only 2 shark sightings, the number of swimmers is 121. When there are more shark sightings, say 12, the number of swimmers go down to 43. So far, this appears to be a negative correlation. As the number of shark sightings go up, the number of swimmers at the reefs go down. Now to determine if this is a truly negative correlation, you will need to test more points. So when the x value is increasing, such as let's look at 5 shark sightings, 8 shark sightings, 11 shark sightings, you could see that in general, the y value decreases. At 5 shark sightings, we had 87 swimmers. When there were 8 shark sightings, it decreased to 66 swimmers. And with 11 shark sightings, it plummeted to 35 swimmers. Now in general, there is a negative correlation here. Notice, however, there are some cases where the number of sightings go up, but so do the number of swimmers. For instance, when there are 8 shark sightings, we have 66 swimmers, and yet when that increased to 9 shark sightings, the number of swimmers at the reef actually also increased to 72 swimmers. This is because this is real-world data, and real-world data is not perfect. You usually won't get the perfect correlation. But in general, as shark sightings increase, the number of swimmers decrease. Now to see if this is a linear relationship or a nonlinear relationship, we need to graph this. A linear relationship has a constant rate of change. That means as one variable increases, the other variable increases or decreases by the same amount. Now it's easiest to see this on a graph. So let's graph the data as a scatter plot. You've already labeled our variables as x and y, so now we need to plot each point. At 5 shark sightings, there are 87 swimmers, so at the x value of 5, we get 87. At 8 shark sightings, there are 66 swimmers, and at 11 shark sightings, there are 35 swimmers. Now, looking at this graph, you could see this negative correlation. Now, after we plotted these points, let's actually look at a graph with all the points plotted. Now, see how the points cluster in a linear fashion? Almost as if it's around a line. As this x value increases, the y value decreases by the same amount, so there is a linear relationship. If there had been a nonlinear relationship, the graph could increase a different amount at each time. So for instance, it could look like this exponential line here, where this line is no longer a straight line, or it could cluster around a curve. Now, look at this graph to see if there are any outliers. Do you see any points that are plotted away from the cluster around the line? Ding, 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 ding. Yes, there is one point away from the cluster at the point 038. This one outlier doesn't change the overall negative correlation or linear relationship because it just doesn't fit with the actual line. This is an outlier, which by definition means that it doesn't fit with the rest of the data. And as I said before, real-world data isn't perfect. Now, great job, and we'll see you working on this next time.